Here we go, chapter 3-1, solving systems of equations. Our game plan today is to take two lines out in space. See my lines, my hands, my yardsticks? And we want to know where they cross. We want the point of intersection. Okay? There are four methods of finding the point of intersection. It is graphically, it is linear combination, it is substitution, or it is determinants. We're going to learn all four methods. Those four methods are quick and easy. However, they can be involved. So the next week and a half, please don't miss. Okay? Graphically is the absolute worst case scenario to use whenever you do it by hand. Why? Because our eyes do not graph well. We do not scale well. We cannot graph anything less than 1/2 units. If I have people try to graph 3/4, they're like, oh, and they don't get their scaling done right. Do you hear what I'm saying? So by hand, we as a population cannot graph accurately enough. So in order to use the graphic calculators, and that's the only way we can actually find the most accurate point of intersection. Yes? Okay? Next slide. Here is the real meat and potatoes of this section.
Meat and potatoes, some kind of good.
You're not allowed to say that.
I was going to that.
Checking your vision. Okay, I understand. It is tiny. I'm conserving paper, so I get yelled at for copying your notes. Would you rather have notes copied or would you rather have tiny notes?
Rather have tiny notes.
Oh, CPC senior.
I mean, I have one.
Hey, have it. Bring it in. I'll do it.
Are you serious?
Hand to God.
Someone said I'll get in trouble if I bring it into school because it's pretty much a computer. It has music on it.
Okay, yes, they're right. But I can give you a flash drive if they're not. Okay, independent. A consistent system means that you actually can see where they're intersecting. We have two possible intersections for consistency. Okay? Either we have one point of intersection where you can actually see the lines crossing. What this means is your slope is always, always, always different. If you have one point of intersection, your slope will be different. Do you hear what I'm saying? Okay? That's independent. However, you have what we call dependent. Dependent means that you have infinitely many solutions. What does that mean actually, Mrs. Yoder? Put that in layman's terms because I think you're speaking a foreign language. Are you listening to me? When you go to homecoming, are you dressed the same way as what you are whenever you come to school?
Yes.
Some people. Some people, generally not. Okay? What you're telling me is you have cosmetically altered the way you look, correct? So what we're going to do is alter cosmetically the look of the line. But its DNA will remain the same, just as your DNA remains the same from whenever you come to school versus when you go to homecoming. Jenna's DNA does not change, and she doesn't morph into a whole different person whenever she goes to homecoming.
I do.
I'm pretty sure you still have the same DNA. Do we understand that? Okay? So what does it mean to cosmetically change? Cosmetically changes means we multiply or divide by a value. Right? Okay. So how did I go from 2x to 6x? Multiplied by 3. How did I go from 5y to 15y? Multiplied by 3. How did I go from -3 to -9? Multiplied by 3. Yes? So what this means is, if we have exactly the same line, that means each line has exactly the same slope with exactly the same y-intercept. And that means every single point on the line is a point of intersection. Why? Because they are exactly the same. Right? Do you see those points? They're exactly the same points. Therefore, they are intersections. Do we agree? Now, how do I write that? You got to have your ugly little braces here. Okay? And then it's parenthesis x comma y. What does that x comma y mean? It's a point. And I want all the points that fall on what line? This line, which is 2x plus 5y is equal to -3. So, how do I denote infinitely many solutions? Braces the point x comma y such that 2 x plus 5y is equal to negative 3 slope. We're going to talk about doing that a lot today, okay? Now, the key is you have to understand that they have the same slope and the same y-intercept. Now, if we have a different slope, but the same everything else, what's my last possibility? Okay, if your slopes are the same, but you have different y-intercepts, what do you have? Railroad tracks, and railroad tracks are what? Parallel lines. So parallel lines will never intersect. Why will parallel lines never intersect? Because they're parallel, and by definition, parallel lines do not cross. So therefore, you have no intersection point. Does that make sense? Now, here's what I want you people to write. Because many of you are still very confused about this. So, write this on your paper somewhere. We have slope. That's what you're comparing. If your slope is different, it automatically means it's consistent, which means it's independent. Which means it has one point of intersection. That's what I'm talking about. Write that on the side or something. Do we understand that? Oh, nobody wants to tell me that I can spell different right? Okay. Now, if it's not different, then what are they? The same. So if it's the same, meaning my slopes are the same, I branch off into two different concepts. And if my slopes are the same, then what is the next DNA thing I need to look at? What else is DNA in an equation? The y-intercept. So now I need to look at my y-intercept. If my y-intercept is the same, and my slope is the same, then I am going to be a consistent dependent. Meaning infinitely many, or x comma y such that, and then write the equation.
You can't spell.
What did I write?
Consistent.
Oh, consistent. I'm going too fast. Yeah, consistent. I am going way too fast. Sorry, guys. But thanks for telling me. Okay. Do we see consistent? Yoder got it right. Second T in there. Okay. If my y-intercept is not the same, that means it's different. Then that means it's not going to be consistent, but what? Inconsistent. Which means there's no solution and the lines are parallel. Yes? I spell everything right this way? Okay. You ready? Okay. Steps in graphing. It's right up here too. Steps in graphing. Solve each equation for y. Find each slope and y-intercept. On your calculator, open a new document, choose graphs, type the first function in the function line, hit the tab key, type the second function, hit menu, analyze, intersections, lower bound, right down. Yada, yada, yada. It's already written down in your notes for you. True statement? Excellent. Let's begin. Step one, what do I do? Solve for y. So I have two equations. Negative 3x plus 2y is equal to 8. And I have x plus 2y is equal to negative 8. I have to solve this thing for y. How do I go about doing that? I'm going to add 3x to both sides. And I have 2y is equal to 3x plus 8. Now what? Divide each and all terms by 2. Is everybody participating today?
Yeah.
What's my slope? My slope is 3 over 2. My y-intercept is 0, 4. Box it in.
Why 0?
Because the y-intercept as always has x 0. Okay? Go to my next one. What am I solving for? So I need to subtract the x. 2y is equal to negative x minus 8. Now what? Divide by 2.
Minus 4.
Y is equal to negative 1/2 x minus 4. What's my slope?
Negative 1 over 2.
What's my y-intercept?
0,
Box it in. Are my slopes the same or different?
different.
Different. So according to my lovely little slope thing, since they're different, what are they?
Perpendicular.
They are consistent and independent, which means now I need to find the point of intersection, right? So how do I find the point of intersection? Go to your calculator. Open a new document. And what do I want that document to be? A graph.
Do you want to say
No, you do not want to say changes. Okay, so now what do I type in? So what was my first function? When I solved it for y, what did I get? 3 divided by 2x plus 4. Enter.
3 divided by 2 plus 4.
Yep. 3 divided by 2, x plus 4 is your first function. How do I find my next, how do I enter my next function? Hit tab. Now what do I do?
3 divided by 2.
Negative 1/2 x minus 4. There's my second function. Do you see it actually cross? So what do I hit? Menu. Then what? Analyze graph. Then what? Intersection. Now look. Look, look, look. Look at me. Look at me. Look at me. See me. Okay. Do we see the dotted line here that's vertical with the hand? You want to move the hand to the left of where the intersection point is and click. Then it says upper bound. Then move it to the right of the intersection. Do you see the shaded region? And click. And check it. It gives you the intersection point.
Where do we put the 1/2 to the left of what?
Anywhere. All you got to do is go to the left. Guys, it's very important that you read and pay attention. I cannot make you put the numbers in correctly. Okay? So what is my point of intersection? So you are going to come right back over here and you're going to type in there negative 4, negative 2, and put braces around it. And the braces indicate that it's a set. And the point of intersection is the set containing. What's POI stand for?
Point of intersection.
Point of intersection is the point negative 4, 2. Negative 4, negative 2, sorry. Shall we do it all over again? Okay.
Yeah, hold on. Please.
I got behind it now. Let's go to the next example, everyone, so we can stay on. If you didn't get that one, go to the next one, okay? Step 1.
How do I get off one?
I got a lot to cover, so stay with me, folks. Solve for y. So I take the 2x plus 4y is equal to 12. And I also take the x plus y is equal to 2. Those are my two functions. So if I'm solving this for y, what's that give you? Subtract the 2x 4y is equal to negative 2x plus 12. Divide each term by 4. And y is equal to negative 1/2 x plus 3. What's my slope? Negative 1/2. What's my y-intercept? 0, 3. Box that information in. Why am I asking you to box that information in?
How did you get negative 1?
Because I need to reduce them. 2 divided by 4, they're both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2.
Will it just be 2?
No. Because the smaller number's on top, not the bottom. Okay, go to the green one over here. What do I do? Subtract x. And I have y is equal to negative x plus 2. What's my slope? Negative 1. What's my y-intercept? 0, 2. Box it in. Are my slopes the same or different? They're different. So what's my type of solution? Consistent, independent, and now how do I find my point of intersection?
Open a new document.
I don't need to open a new document. Let's do Control Doc so you can get a new calculator page, a new graphs page. So Control Doc. Now what do I type in my first one?
So, negative
Negative half x plus 3. Hit enter. How do I do my other one? Hit tab. Everyone with me? Now what's my second equation? Negative x plus 2. Enter. Do you see the two functions? How do I find the point of intersection? Menu, analyze, intersection. Do you see the hand? Where does that go? To the left of the point of intersection. Click, shaded it, and then click again. And what's your point of intersection? Negative 2, positive 4.
Just put anywhere.
Yep. Anywhere to the left and anywhere to the right of it. So my POI, braces, negative 2, 4, and braces. Do we see this? This is like problems 30, 28, 30, 32, and 34. So 28 through 34. Maybe 30 through 36. I can't remember. It is. It's 30 through 36. That's what this is like. So this is what you're going to do for problems 30 through 36. Yes? Okay? Point of intersection. POI.
Definitely just waiting whenever I get it.
It's like problems 30 through 36.
And it's different.
Okay, we're going to skip problem 29, and we're going to go on to the next slide. We're going to skip problem 29, we're going to go on to the next slide. Just for time-wise for you. Okay, are we ready? Without graphing. In other words, I don't want you to graph it. I want you to tell me if it's independent, dependent, or inconsistent. What does independent mean? How many points of intersection do I have if I'm independent? 1. If I'm dependent. Many. If I'm independent. If I am inconsistent. None. So put that up top here so that you know it. I'm looking for 1, many, or 0. Okay? 1, many, or 0. Okay? So what do? Do my steps change? My steps don't change. I still got to solve for y. So 4y minus 2x is equal to 6. So I'm going to add the 2x. So 4y is equal to 2x plus 6. Divide each and every term by 4. And y is equal to 1/2 x because they're both divisible by 2. And 3 over 2 because they're both divisible by 2. What's my slope? 1/2. What's my y-intercept? 0, 3 over 2. Box it in. Why am I boxing that in? Because I need to look at it here in a little bit. So I'm going to come right back over here and do the 8y is equal to 4x minus 12.
Well,
What do I do? Divide by 8. Y is equal to 1/2 x minus 3 over 2. What's my slope? What's my slope? 1/2. What's my y-intercept? 0, negative 3 over 2. Box it in. Now, are my slopes the same or different? They're the same. So now that I know my slopes are the same, what do I have to look at? I need to look at my y-intercepts. Are they the same or different? My y-intercepts are different. Since they're different, what is that going to be? It's going to be inconsistent, meaning they are not going to cross because they are parallel lines. Do we see it?
yeah.
Yay!
What should I say to
Should
my
say
head?
the section notes are not very nice. Okay? Do we see this? Let's try again.
Right.
Come on. What do I do?
Solve for what?
Solve for y. So negative 3x plus y is equal to 4. Add the 3x. Y is equal to 3x plus 4. What's my slope? 3. What's my y-intercept? 0, 4. Excellent job, guys. Box it in. Yes?
Yeah.
Okay, over here. X minus 1/3 y is equal to 1. I'm solving for what? So what do? Subtract x. Negative 1/3 y is equal to negative x plus 1. How do I get rid of that negative 1/3? When you divide by negative 1/3, you're actually multiplying by the reciprocal, and the reciprocal here would be negative 3, but put parentheses around that right-hand side. Because you're multiplying not just one term, but both terms. Does everybody see that? So this is going to be y is equal to, distribute, 3x minus 3. What's my slope? Nope. Positive 3. And my y-intercept? 0, negative 3. Box it in. My slope's the same or different? Same. Are my y-intercepts the same or different? They're different. So what's that going to be? Inconsistent. Are we getting it yet?
Yes.
Yes?
Yes. We're facing her.
No solution, parallel lines. Okay, slide B there. Solve for y, solve for y. I have no idea right now. Subtract 2x. 3y is equal to negative 2x plus 1. Divide each term by 3. Y is equal to negative 2/3 x plus 1/3. Slope? Negative 2 over 3. Y-intercept? 0, 1/3. Box it. Coming back. Subtract 4x. Y is equal to negative 4x minus 3. What's your slope? 4. Can I stop right there? Why can I stop? Because they're different. Since they're different, what do I know? It's consistent, which means it's independent because they're different. Did we get that? If you have all the information that you need, don't go any further.
It seems like consistent should be the one that's the same.
But it's not. I know, I'm not gonna get messed up. I get through with it.
Okay, last problem. Y is equal to 2x minus 3. It's already done. What's my slope? 2. What's my y-intercept? 0, negative 3. And box it in. Over here, 6x minus 3y is equal to 9. What do I do? Subtract 6x. Negative 3y is equal to negative 6x plus 9. Now what? Divide by negative 3. Y is equal to 2x minus 3. What's my slope? What's my slope? 2. What's my y-intercept? 0, negative 3. Box it in. Are my slopes the same or different? Same. Are my y-intercepts the same or different? The same. So what does that tell you? They are consistent and it's dependent. And what's my point of intersection? Oh, come on. Remember it's the really long one? Put the braces, put the point, put the colon, and then put the equation. So what equation will it be? Y is equal to 2x minus 3. I know that notation's super duper funny to you, but you guys will get it if you use it enough. Okay, this is like this is like 18 through 28 even, and 38 and 40. Yep. So tonight, your homework is 18 through 40 even. What do you have to do today before you leave in class? I need you to do the 4 problems in the calculator, which would be problems 30 through 36. Okay, because those are the ones that you have to do the point of intersection in class. Out of those 4 problems that you have to do, 3 of them are already solved for Y. You're welcome. You're welcome, Caitlin. The rest of you. Thank you. Okay. I said stop her. Okay. Now, any questions over last night and tonight's work, what we need to be doing, I should say? Are we good? Yeah. Okay, tomorrow when you come in, I'm not giving you any additional time. Tomorrow I'm going to start right into the linear combination. Thursday I'm going to start right into substitution. And then Friday is going to be the day that you guys can work in groups to, or I should say, to finish up anything that you owe me for calculator or for test-wise for me. Any questions over what I just said? No. We're good to go? That's your homework, 18 through 40 even. I've done an example on every one of them.
30 through 36.
Yep. Left bound, right bound. Then you analyze point of intersection, left bound, right bound.